Welcome to another exercise for the workbook statistics. This time I'm going to talk about measures of central tendency, or more to the point about quantiles, box plots, percentiles and so forth. Our task in this case is, a survey with pupils about the time spent daily online on the internet resulted in the following data set, giving us these 10 observations. And our question or task here, calculate based on the dataset the statistics required for the construction of a box plot. So before we're going to start doing this, we're first going to reorder our dataset. So I'm going to copy the original dataset. Then I'm going to order this in an ascending fashion. So from smallest to largest value, because this will make the next step much easier, because there we need the inherent order in our data set. So that's our result. That's what we're going to work with later on. That's why I'm going to copy this here. And then to construct a box plot, I need to determine 5 statistics. I'm going to start with the smallest one. That's the lower antenna of the box plot. This is given by the minimum. The minimum is actually the first entry in my data set. It's the smallest value, so here it's 1. Then I'm going to continue with the first quartile, which is the 25% percentile. To get this, I'm first going to multiply 0.25, because of the 25%, with the number of observations. Here I have 10 observations, so I'm going to calculate 0.25 times 10. The result in this case is 2.5. Here I have to check, is this an integer or not an integer? If this is an integer, I would have to use a slightly different approach, but since this is not an integer, those half brackets, which I see on the left and the right of the number, come into play, and they mean I'm going to round up. So I'm going to find the next integer. This doesn't matter what's after the decimal point. I'm always going to round up if this is non-integer. So here I'm rounding up to 3. This means the first quartile, which is the lower part of the box, actually is given by the third observation, which here is 2. So my first quartile is 2. Then the next part is the median. Usually in the box plot, the median is a line inside the box. The median depends, regarding the formula I'm going to use, on whether I have an even or an odd number of observations. Here in this case, I have 10 observations. So I have an even number of observations. This implies I'm going to use this formula. Going to multiply the number of observations with 1/2, and then at this point add 1 to this. So I get 5 here and 6 here. So I'm taking the 5th and the 6th observation and take the average of those two numbers. So in this case, the average of 3 and 4, giving me a median of 3.5. I could also interpret this as I'm going to take the two values in the middle of the data set. That's here the 3 and the 4. I have 4 on the left, 4 on the right. So the two values in the middle, and I'm going to take the average thereof. And it's exactly the same thing here. So that was the line in the middle of the box. Then I'm going for the upper boundary of the box, which is the third quartile. This I get similarly to the first quartile. Only instead of 25%, here I'm working with 75%. So I'm going to multiply 0.75 with 10, giving me 7.5. Again, this is not an integer, so I'm going to round up. I'm getting 8. So I'm going to take the 8th observation, which here is also 8. So the 8 is my third quartile, the upper bound of the box, leaving me only with the last value. That's a value for the upper antenna. This is simply the maximum. The maximum is the largest value in the data set, or in my ordered data set, the last one. So here I have 11 for the maximum for the upper antenna. Well, that's then everything there is to the construction of a box plot. So I hope you enjoyed this session. I'm going to say goodbye and see you next time.